we are going to have a look at the costing of metals. How do we cost the metals and what happened? What are the issues that related to the costing? What are the problems that we occur, that we see during the costing process? And what are the remedies? How to get rid of these issues and problems in costing? Now, the process of costing, we produce a component from a metal by melting the metal and then pouring it into a mold and then waiting it to solidify and then removing the mold to get the cast product. Now, then there are certain advantages and certain disadvantages of casting as well. Now, if you are developing some type of intricate shapes, we prefer casting. Okay, if we don't want these to be casted, we can use machining process as well. The casting is less expensive as compared to machining. There are some type of casting known as investment casting, which the jewelers use for very expensive components and so on, for a unique design and so on. Yeah, so that's a little bit more expensive. It's known as investment casting, but the normal casting is not that expensive as compared to machining. In casting, we can have an hollow component as well. Different shape, different size can be achieved. Okay, now when we do the casting, now we transfer the molten metal, which is here, the molten metal, and we transfer that one manually into the cast mold. Or sometimes we actually use a big ladle, like which is shown in the on the other side. So it's up to you how you want to use it. Now, when the molten metal is poured into a mold, what actually happens is the temperature drops straight away. So you can see the cooling of the liquid, straight away temperature drops. Initially, the temperature drop is massive. Reason? Because the mold is cold, the molten metal is higher than its melting point. So it just cools down very quickly. When it cools down very quickly, then it tries to solidify. But when something is solidifying, the temperature does not change. So from A to B, there is no temperature change. Temperature gradient is 0. Then at B, the freezing, all the liquid metal has frozen, is converted into solid. Now that solid metal is still hot. So over a period of time, the solid molten block of casted iron is going to not solidify, it's going to cool down. Hence, you see the curve from B all the way down. If you want A to B, depending on the shape and the size, if it's a big massive component and a lot of molten metal, the line from A to B is going to be massive. The time it takes will be massive. If the surface area of the shape is in such a way that it has massive surface area, then what will actually happen is the cooling curve is going to be more faster cooling rate. The slowest cooling rate we achieve when we do spherical object like a ball or solid balls, that because that has a minimum surface area kind of thing. Yeah, so that's another thing. Okay, now we done that one in the previous session. When the cast in metal start to cast, the liquid start to solidify. The liquid will form a tiny film next to the surface of the mold, the molten mold wall, and that's where the solid will form. And then it actually penetrates towards the center. So if you got a casted object and you just want to measure the property at the ends and at the center, you will have different properties in terms of strength, in terms of hardness, and in terms of ductility as well. We do not want the difference in properties. We don't want differentiated properties. We want homogenized property. So what usually we do is, after the casting process, we want to make it homogeneous. We want to put some time in a furnace, so we want it slow cooling. So all the dendrites and all these, either we can break it, we don't let it form, but even if they formed, we want to actually let all the chemical homogenize, mix together. Now what is called, if we look at liquid diffusion, if you got a water and you drop a very cold water, you drop a ink, you can actually see the ink diffusing into the water. You can do the same. Hot water, drop a ink, the ink will diffuse faster. Similar thing happen in solid. There's a thing called solid diffusion. Solid diffusion is the same thing, but it happened a lot slower than the liquid diffusion. So we can increase our process, increase the diffusion rate by heating the material, by putting it at elevated temperature. We can actually, when the solidification is happening, we can actually make these dendrites not grow by either using an ultrasonic method, where we put the ultrasonic waves, which breaks these dendrites, so they don't form. Hence, we have a uniform properties throughout. We covered that one in the previous session, so I'm just going to skip that one. It's about homogenization, it's about macro segregation and micro segregation. So have a look at my previous videos, and I've explained that well. Now, then we have different type of metal casting process. Now, one is known as expandable mold process. This is a process where you form the mold in the sand, and sacrificed, it's broken to remove the part, so you can reuse the sand again and again. The way they got is, they got the sand, and they got from the sugar production industry, molasses, the kind of gluey stuff that comes from the sugar cane. They mix that with sand, and they use that to create the mold. Advantage is you can form more complex shapes. Other advantage, you can use the sand again and again and again. So it's and the molasses you put from the sugarcane industry, it's actually a kind of raw material which they have to throw away, which the casting industry use. um, the disadvantage is a slow process. The production rate is limited, not very fast production rate. Then we go up, and one other thing is surface finish is not very good. Permanent mold process. Now in that one, the mold is made up of metal, and it can be used again and again and again. Permanent mold, the mold is itself is expensive. And the other issue with that one is the geometrical limitation. You cannot get all the shapes, all the intricate shapes and sizes, because you can't sacrifice the mold. Then we got the investment mold process. Investment mold process is, you form the mold by a wax model. Once the wax model is formed, you actually dip that wax model in kind of like slurry, and which actually solidify on the top of that mold. And then you put that one in an oven at not a very high temperature, 100 200 degrees centigrade. 100 200 is very good temperature. It melts all the wax inside. Now, so you got an intricate mold, and then that mold you pour the liquid metal inside, and you get that one. Later on, what you do, you put that on a ultrasonic machines like vibrators, which actually vibrates it and breaks the mold, and you get the mold, the casted object from there. The disadvantage is it's time consuming, very time consuming, and we need a wax model for that one. Now, next one, sand casting. So this is the sand casted mold. This is a mold. Now, we have a geometry of the mold as well. So I will explain that in the next slide. You put the molten metal here. This part where the molten metals actually goes in is known as the runner. On the other end, it should rise, and we call that riser. The number of the runner and riser depends on the geometry of that one, of the component you're trying to cast. Too little mold, too if let's put, if the calculations is wrong, there will be shrinkage, which means your casted object is not going to be fine. If the object is quite long and you got only one runner, you put the molten metal in and it will be short casted. It means the molten metal is not going to go through all the end. It will go halfway and solidify. So you need to have multiple runners and risers. Okay, now the next one. Okay, now when it cooled down, you can actually this is not a very good example, but when initially what we do is you have these molds, which you can see the silver one. You just have the sand, and in the sand you put half of the mold, yeah, and just level the sand, press it, and then you just do the same on the other side of the mold. You put them both of the mold together, but before you put them together, you just arrange a channel for the flow of the metal, the runner and the riser, and so on. Between them, you spray a liquid, not liquid, solid graphite to make sure the metal does not stick with the sand. Okay, now you can see here, that thing is a riser. This thing is where you're going to pour it. Yeah, you're going to pour the liquid in. This where the metal goes towards the casted object, that's known as gate. Runner is where the metal runs and then it enters the gate. Sometime for some different shapes we want to have a side riser. Side riser is there to make sure you have a certain amount of molten metal that's there, so it does, in case of shrinkage, that metal can be supplied to casting. And we got a top riser. Top riser just give you an idea that yes, the metal has reached on the other side. When it's solidified, the top riser is going to shrink, and you can actually see the shrinkage cavity formed at the top riser. Sand casting, the advantages and disadvantages. The patterns are inexpensive to produce. There is no need for additional equipment, machinery. Sand can be reused over and over again. Again, sometimes it's difficult to produce the intricate shapes. For that one, we like investment casting. Not a very good surface finish. We have to do the secondary process. Sometime inclusions, when you're pouring it in, what actually happen? The sand particle can go into the casting, and that sand particle will act as a stress riser, which can cause some kind of degradation in the tensile strength, mechanical properties, and so on. Sometimes the air bubbles can go in and it can cause cavitation, and which can result into stress risers as well. Okay,